Okay, here is the manual way to test it, or manual or by the textbook. Every textbook will tell you to do this. They will tell you in disclaimer, this is in every manufacturer's textbook. They're going to tell you to this procedure to check your sensor. Take the sensor out of the vehicle. Now keep in mind, if I'm going to take this coolant temperature sensor out of the vehicle, this end is down in coolant. This is a brand new sensor. It's never been in a car. Still has the thread sealant on it. This is just thread sealant. Don't use pipe tape to cover this because this we need to keep it from leaking, but this is actually a special thread sealant that's not going to get rid of our ground. On a lot of these sensors, they're one wire. Some are one wire. If they are, it's got to ground through these threads. This sensor, it really doesn't matter. It is two wire. So it gets a 5 volt sent out to it on the signal wire, coolant signal wire, and the other wire is a ground through the computer. And we'll discuss that in just a little bit. So this one's 2 wire. If it was 1 wire, then it is going to ground through this case. But that won't work on this. It's got a plastic intake, and there's another reason why we ground it through the computer itself instead of here. So what they will tell you to do is to hook your test leads up to it, which is kind of hard unless you have a connector, or I use small alligator clips. So I'm going to hook a small alligator clip on here to this one, to one terminal, and then I've got another alligator clip and I'm going to hook it up to the other one. I've got to make sure they do not touch. Now I'm going to use this meter, so I'm going to take one terminal and hook to one of them. Now we're reading resistance. What is the resistance of this sensor? And that's what we're looking for. So I'm going to try to get this standing back up for you. And I know you can't read it. I'm going to move in closer. But I want you to see the hookup. So I'm going to hook one connector onto one side. I'm going to take the other connector and hook onto the other side of this. And so I make connection with it. Mind you, just make sure they do not touch each other. So I'm going to get this out of my hands so it'll sit, maybe. Because this is going to be kind of neat, maybe. We'll see what happens. Now, what you can see, it is reading 7,580 ohms. A little hard, and I know it's a little hard to see in the camera, but there is a K ohm right here in the bottom of the screen. That does say K ohms, so that's 7,620 right now. And you can see it's actually cooling off a little bit. The resistance is going up because I've taken it out of my hand. Now this is kind of cool. What they will tell you to do is to dangle this sensor down in some boiling water with a thermometer in it. So put it in some boiling water with a thermometer in it. Water boils here in Winston-Salem at about 210 degrees because we're up at about 800 feet. It's 212 degrees at sea level, but we are elevated a little bit. So we're somewhere around 210, 209 degrees. And bring the water up to boiling because it's going to stay steady at that point, and read the ohm meter and see what it reads. Then I'm going to take that ohm meter reading, look at the thermometer that is in the water to give me the temperature, and I'm going to go to the book and compare it. Kind of a pain to do. Now here's the sensor. Now what I'm going to do is, you can see we're reading 7,910 ohms. So what I'm going to do is grab hold of this, and I'm just going to squeeze it. I've got hold of this thing, and looks like I just shorted the terminals out. So let me put my camera down, see if I can unshort them real quick, because it is pretty doggone close in here. And so now I'm just holding on to the end of this, and you should see the numbers are going down just off of the heat of my hand. My body temperature, which is about 98 degrees, and I'm losing contact here and there, and about 98 degrees Fahrenheit, and I'm losing it, but you saw it a little bit there. The ohm meter, the resistance reading was starting to drop. Now this is how they want you to test it. As you can see, it's kind of a pain to hook it up and to test that. And then while you're doing all this, they want you to dangle this down in hot water. But you got to be careful. You can't let the water get splash up to here, because then water gets inside here and it'll short the terminals out. So then you'll have a very low ohm meter resistance and it won't be accurate. So the idea is I've got to get a constant temperature here, take a reading, go to the book, and they all say the same thing, to check it in boiling water and then compare the resistance reading to the chart in the service manual. Well, what if your problem was at a different temperature? What if your problem only occurred when it was cold? Or maybe it happened during the warm-up cycle. When it got to about 120 degrees, maybe there was an open in this sensor at 120 degrees, but once you get past that, it comes back. I'm still going to have a code set for it, but every time I check it, it's going to be reading right. So that's the idea of doing the graph. If I do that graph and let it warm all the way up, and then I should see that graph, the voltage should steadily go down as the temperature steadily goes up, and it should be nice and steady with no spikes. If I had a dead spot in the center, then I might get a drop in the reading, a drastic drop in the reading. Usually doesn't drop, just a little bit. If you see a few little spikes, it's probably due to a bad connection somewhere. But if you're seeing big spikes, maybe they go all the way down to 0 or all the way up to 4, it's probably something going on inside of this sensor. The thermistor down in the end is either shorting out or it's opening circuit intermittently while it's warming up, and that's causing your problem.